Okie dokie, mixed review here. Oh boy. All right. Pain reliever is taken in 220 milligram dosages and has a half-life of 12 hours. So look at that. Look at that and understand what this means. Half-life means reduces by half every 12 hours, right? Do you see that? Dividing by 12 in the T. Make sure you know to do that if you're writing your own formula. This function can be used to model the situation according to the function which statement is true. Every hour, the amount of pain reliever is cut in half. No, half-life means half of the amount is left after 12 hours, or reduces by half in 12 hours. So in 12 hours, there's no pain reliever. No, false. In 24 hours, there is no pain reliever. No, false. In 12 hours, 110 milligrams is remaining. Well, if they're starting with 220, yes, true. Okay. Number 2, for a given time x in seconds, an electric current y can be represented by this formula. Which equation is not equivalent? This is actually really mean, and so there's a couple ways you can go about this. Let me first talk to you about the real way, and then I'll give you an insight into what I would do if I were you. What this is testing is if you know your exponent rules. So first of all, they're distributing this. You see that? 2.5 times. So in all of those, that's distributed. But then this is kind of messed up, right? They keep breaking up the negative 0.10x. So this right here, this first example, is just them distributing. So they haven't changed the exponent at all. So this is true. This is fine. So it's not that one. The next one, everything else is the same, but they've broken up that exponent. We know that an exponent raised to another exponent, you multiply. So if you multiply 2 times 0.05, you get negative 0.10x, which is the same as this one. So that one is also true. Okay. Number 3, they distributed. And then we also know that a negative exponent means put it on the bottom, and the exponent comes positive. So yeah, that's actually true. And the last one says negative 2 and 0.05, but we know that if two things are multiplied, that you're supposed to add their exponents, right? And that's not equivalent. So this is not equivalent, okay? The other way to do it, the easiest way to do it, is pick a number for x. So let me clear all this junk out, and I'll just show you I'll try to be really fast, even though typing this isn't probably going to go really fast. Let's say, let's store a fun value for x. Let's store 7, and I'll store it for k. All right, so the first one, 2.5, 1 minus 2.7 to the negative 0.10k. That number, okay. 2.5 minus 2.5, 2.7 to the negative 0.10k. Same, right? So I would go through all the choices, and then so choice 4, 2.5 minus 2.5, 2.7 to the negative 2 times 2.7 to the, oh, that's still in the exponent, sorry, times 2.7, sorry, I'm a little slow, 0.05, okay? Not the same. So just deciding which, if they're equivalent. You can always do that too. All right, that's what I would do if I were you. Okay, so now we've got Judy. Ugh, Judy. Judy puts $5,000 into an investment account with interest compounded continuously. Compounded continuously means A equals PERT. Okay. Which approximate annual interest rate is needed for the account to grow to $9,110 after 30 years? So 9110 equals 5,000 e to the r times 30. Divide by 5,000. So 911 over 500 is equal to e to the 30r. Change to log form, so ln of 911 over 500 is equal to 30R divided by 30. So let's go to here. ln of 911 over 500 divided by 30 is 0.01999. Okay, so 0.02. R is 0.02, which means the percent is 2%. Okay. Number 4, that's quite the doozy here. It's not difficult, don't let it scare you. So, if AE to the BT is equal to C, then solve for T. Well, this isn't actually as bad as you think it is. We know in all of these exponential equations, in order to solve for the exponent, we divide by the constant, right? Divide by the initial to get E by itself. Then we change the form. Log base E is ln of C over A is equal to BT. Solve for T means divide by B. So ln of C over A divided by B is choice 3. Okay. 5. G of x represents exponential growth. Which statement about g of x is false? A is greater than 0. True. B is greater than 1. Well, if it's growth, it's got to be greater than 1, so that's got to be true. The y-intercept is 0a. Well, if x is 0, b to the 0 is 1. So yeah, 1 times a will be a. That's true. The asymptote is y equals 0. Yeah, there's no vertical shift. True. The x-intercept is b0. False, because we know exponentials don't cross x-axis. So, choice 4. Okie dokie. So let's see. Researchers in a local area found that the population of rabbits with an initial population of 20 grew continuously. So again, the PERT, at a rate of 5% per month. The fox population had an initial value of 30 and grew continuously, PERT, at 3%. Find to the nearest tenth of a month how long it takes for the populations to be equal. So we have rabbit populations with respect to time. Let's see, we've got 20 to start, E, 0.05 t. We've got fox population, an initial value of 30, E to the 0.03 t. We want to find where these two things are equal. I could set them equal and try to solve. It's going to turn out to be a mess. So I'm actually going to use my graph. So let's go in here. 20e to the 0.05x, 30e to the 0.03x. Now you can't see a gosh darn thing, and that's not because your calculator is broken. That's because your brain is broken. You're not thinking about what we're talking about here. We're talking about time, right? So I don't care about -10. I like to make this -1. We're starting with populations of 20 and 30. So I'm going to make this 50. Now we're talking about time. And we're talking about months. So obviously 10 isn't enough. So 24 would be 2 years. 36 would be 3. Let's see what 36 does. Okay. Well, my graph doesn't go high enough now. So I'm going to go back up here. Maybe I'll take just a 200. I don't know. Oh, found it. Okay. So I can see their intersection. I hate the labels, by the way. So menu, analyze, intersection, click, click. It asks for time, so 20.27 to the nearest tenth of a month. So 20.27 t equals 20.3 months. All right. Use the laws of exponents to simplify the expression. Yay! Okay, so negative exponents. So first, wait, rewind, stop. Order of operations says deal with the inside first. So on the inside, I notice that both of these are in the wrong location. So I'm going to move the 10 here and the 6 here. Okay, now they're both positive. I've got 10 on the top, 6 on the bottom, which means I've really got 4 left on top. To the 1/2. Power to a power, you multiply. 4 times 1/2 is 2. M squared. You can test this by storing a value. You can test this by storing a value. So let's clear this out. Go here. I'm going to pick, oh, what's an ugly number? 5. I'm going to store it for M. The first thing written on the paper was M to the negative 10. I'm sorry, M to the negative 6 over M to the negative 10 to the 1/2. Okay, it's 25. Is that the same as M squared? Yes. I know I did it right. Oh, number 8. Solve for all values of x. This hasn't shown up in our review really at all, so pay attention. Hello. We did a bunch of these in Unit 2, and we reviewed them in Unit 6, so you are responsible for knowing this. So, in order to get rid of this exponent of 4/3, we raise to the reciprocal exponent of 3/4. It is not multiplication, it is an exponent, because 4/3 times 3/4 is 1. So x plus 2 to the first is just x plus 2. 81 to the 3/4. That's really the 4th root of 81 cubed. The 4th root of 81 is 3. Cubed is 27. Subtract 2. X is 25. You can always check those. Okay. What is the value of x? A lot of people in the room probably think they're supposed to do something here. Stop. Freeze. X is by itself. Use your calculator. Log base 2 of 16. Is 4. It's over. X equals 4. Yes, that was an easy question. Average value. Average rate of change. Average value. Oh, why did I write average value? Why didn't I do average rate of change? Sorry, I meant average rate of change. ROC. Okay, so change in y over change in x. X's are 4 and 2. So 2 to the 4th minus 2 squared. You could use your calculator. 2 to the 4th minus 2 squared over 4 minus 2 is 6. Nailed it.